Okay, so now we are looking at solving two-step equations. We have, in week one, we looked at solving one-step equations. And what I said was to do the opposite operation, right? This is what, when we're solving equations, we're doing the opposite operations, or in simpler ways, bed mass in reverse. Okay, we're doing bed mass backwards. So this is not a two-step equation, it's a one-step equation, because one thing is happening to x, and if I was in class with you, I'd say, what's happening to x? And I look here, and I see that I'm adding 2 to x, so I want to do the opposite of that operation. The opposite of adding 2, that's subtracting 2. Right? The opposite of positive 2 is a negative 2. And whatever I do to one side, I have to do to the other. So I'm going to subtract 2 from 7 as well. Now, what does that equal? So, positive 2 minus 2 is going to be 0. That's why we do it. We want to get rid of anything that's around x. We're going to do the opposite thing. So, these two are gone now. I'm left with just x on that side. 7 minus 2 is 5. All right, now that's the answer. 5 plus 2 is 7. That's what we're looking for now. It's not exactly that difficult, but we're starting with some easy examples, right? So let's fill in the boxes here. What operations are being applied to x? We're adding 2. So what would the opposite operation be? Subtracting 2. This is what we did. Okay, now let's look at this. What operations are being applied to x? If I look at the equation there, we are subtracting 2. So the opposite of that would be to add 2. So what operation is being applied to x? Subtracting 2. The opposite is to add 2. So let's add 2. But whatever I do to one side, I have to do the other. That's why it's an equation. Both sides have to be the same. These two, negative 2 and positive 2, become 0. They're gone. They're a zero sum. So I'm left with just x. And 8 plus 2 is 10. So that's the value of x. 10 minus 2 is 8. That's what we were looking for. What was that number that would make the equation true? What minus 2 was 8? So now here what we're looking for is something divided by 3 is equal to negative 5. So the way we do that is we want to isolate x. Isolate x, get x by itself. So we think bed mass in reverse. What operations are being applied to x? Well, I'm dividing by 3. And what's the opposite of dividing by 3? Multiplying by 3. So I'm just going to rewrite the question because it'll be easier for me to show what I'm doing. So I'm going to multiply both sides by 3. So I'm going to multiply 3 here, multiply 3 there. So now when I'm multiplying here, this 3 and this 3, they're being divided, right? They're on opposite sides of this line. Now, I didn't draw the line all the way across, but if you imagine that line going all the way across, it'd be 3 divided by 3. And 3 divided by 3 is 1. So I'm left with 1x. These cancel out, as we say. So I have x is equal to, excuse me, negative 5 times 3 is negative 15. Excuse me as I drink some water. Adding some sound effects for you. All right, now, x is on the opposite side, but that's okay, it doesn't matter. Don't be confused here. It's 4 minus x, but what's happening to x? This 4 is actually positive, right? It's not a negative 4. The sign in front, if there was one, would be positive. So what's happening to x? I am adding 4. Oops, adding. But there's a negative in front of x. So when there's a negative in front of a variable, that means there's a negative 1 there. So we're also multiplying by negative 1. So the opposite operations would be to subtract 4 and divide by negative 1. And there's a reason why I did it in that order. Why I wrote adding first and multiplying, and over here subtracting and divide. Because at the top I highlighted BEDMAS in reverse, opposite operations, or inverse operations. So the first thing I want to look for is there any adding or subtracting? The AS part of BEDMAS, and I see adding, I'm adding 4. Then I look for any multiplying or dividing, and I saw that there's a negative in front of x, which means we're multiplying by negative 1. So now when I'm thinking the opposite operations, I'm doing that order as well. Subtract and then divide by negative 1. So let's subtract the 4. But whatever I do to this side, I have to do the other. So I'm going to subtract 4 over there. 9 minus 4 is 5. 4 minus 4 is 0. That's why we did it. To get rid of it. Go away. And what's left? After these are gone, I have negative x on that side. But now I need to get rid of that negative in front of x. So we do the second thing we said we're going to do. I subtracted 4, but now I need to divide by negative 1. Choose a different color. Maybe I can change like this. Let's see. Color. Cool. Change to black. So I'm going to divide by negative 1. Okay, remember, this is not, I'm not subtracting here. This here I was subtracting, but this line means division. So I'm dividing by negative 1. So there's an imaginary or invisible 1 that's in front here. So negative 1 divided by negative 1, that makes 1. So I'm left with 1x, or just x on that side. And 5 divided by negative 1 makes negative 5. And that's my answer. We're done. We figured it out. Up here, we're trying to figure out 9 is equal to 4 minus something. Right? 9 is equal to 4 minus what? Well, 4 minus negative 5. That's what we figured out. I know. Mind-blowing. What's happening to x here? We have 2x equals 10. What's the operation between 2 and x there? I don't see a sign. So if there's no sign, that means multiplication. So we're multiplying by 2. And the opposite is to divide by 2. So I want to divide by 2. So I'm going to draw the line, put 2, but whatever I do to one side, I have to do to the other. These 2's cancel out. 2 divided by 2 is 1. So I'm left with just 1x. 10 divided by 2 is 5. I'm trying to write neater. Okay, so that's what we figured out. 2 times what is 10? Well, we already knew that. We didn't really need to do algebra to do that, but we're just trying simpler equations. All right, so now what's happening to x? Looking here, I see there's a -3 in front of the x, and there's a +4. -3, +4. Now, what are they doing? The -3 is right next, touching the x. No sign in between. There's nothing in there. So that means multiplication. That's not what I'm looking for first. I'm looking for BEDMAS in reverse. Can I write fast enough? BEDMAS in reverse. So, addition. That's what I'm going to get rid of first. That's what I'm thinking about first. What operations are being applied to x? We are adding 4. And the opposite of that would be to subtract 4. Okay, so let's do that, and then we'll write the next thing. I'm going to subtract 4. Oh my gosh, there's nothing there. I guess I made a mistake. Let's put a number there. Let's see. Let's say 31. Okay, so put a 31 there if there's no number there for you. If there is a number, I don't know why the number's missing. Anyways, put number 31 there, and we'll subtract 4. Now, over here we got 4 minus 4. Those are like terms, that's what we're doing. 4 minus 4, that's 0, it's gone. So we're going to get rid of this, it's zero sum. They're gone. So I'm left with just -3x. On this side here, 31 minus 4 would be 27. So now what's happening to x? What's that -3 in front of the x doing? X is not isolated, it's not by itself. So that -3 is multiplying the x, multiplying by -3. So the opposite of that is to divide by 3. Sorry about my writing, I'm still getting used to this pen. So let's divide. Remember that line means division by -3. That's 1. So x is equal to 27 divided by -3 makes -9. So we figured out what does x mean in this equation up here. -3 times something plus 4 is equal to 31. Well, we figured it out. It's -9. -3 times -9 plus 4 is 31. All right. Make sure to do the practice questions as well, and I'll see you next time.